All right, happy Monday. Here's this week's packet. The first page or two are kind of ridiculous, but after that, it's pretty easy. So I'm gonna walk you through the first couple pages, like step by step by step, and then I'll cut you loose on the rest of them. So the first page is a little bit intimidating. You got this whole big read a problem. It says Jeff runs 3/5 mile each day. He wants to know how many days he has to run before he has run a whole number of miles. So he's running a fraction, 3/5. If he runs 3/5 one day, that gets him to here, right? He runs 3/5, and then he runs another 3/5 the next day, and then another 3/5 the day after that. And so you can see he's got 3/5, then 6/5, and then 9/5. But he's not landing on these whole number, 1, 2, 3, right? So he's got 1 day, 2 day, 3 day, 4 days, and on his 5th day, he ends up landing right on 3 miles for his total. Now, this goes through and explains step by step what I just talked about. But I think the best way to do it will be to look at problem number 1 and kind of explain that way. So let's take a look at problem 1. Problem 1 says, Lena runs 2/3 mile each day. She wants to know how many days she has to run before she has run a whole number of miles. So the same thing Jeff was trying to do. I'm going to bring in some of these pattern blocks. Okay, so if this is 1 whole mile, then the blue pieces, 3 of them make up 1 whole mile, which then makes these blue pieces each 1/3, 1 out of 3. So a blue piece is 1/3. So this is saying that she runs 2/3 of a mile each day. So that means she's running this much each day. Get these all lined up. So she's running 2/3, but there's a third empty. And so then the next day, she'll also run 2/3. And the next day, she'll also run 2/3. And so she wants to know how long before she's run a total a whole number. So what I can do is I can take this piece there, and then let's see about if she can fill up another whole mile. So there we go. So now she's run 2 full miles, and let's see how many days that took her, right? She goes 2/3, 2/3, 2/3. So 1 day, 2 day, 3 days it will take her to run a whole number of miles, which will be 2 miles. So 2/3, 2/3, and 2/3. Just because I'm going to slide this paper over, and I'm going to do that math over here. I'm going to fold it because it might be handy for us to look back. So in this case, for problem 1, I'll actually come down just a little bit further to get closer. We found out that 2/3 plus 2/3 plus 2/3 equaled, and from last week and from the previous weeks, we know that when we add numbers and the bottom number is the same, when the denominator is the same, we just add right across the top. 2, 4, 6. 6/3. And it makes kind of sense, right? 3 can go right into 6. So it takes 2 3s to make a 6. And so if I can change this back to a whole number, how many 3s can I pull out of 6? 2 full ones. All right. So 2/3, 2/3, 2/3. So it took her, not 2, it took her 3 days. How many days? Now, like I said, I'm gonna walk you through each of these first 5 problems. So if you think you want to give these a try without me walking you through it, you can just skip ahead to where I'm done talking about this stuff, or you can pause, try to do them, and then watch me do them. But these and the next ones in the next page, they're kind of diabolical. It's got some fraction work for you in them, but it almost seems like a riddle the way it's written. So I don't want anything. I don't want big blowups at the house. I don't want parents and kids arguing about math problems. So I'm just going to gently walk you through these first ones, and then after that, the rest of the packet's easy. You guys can cut and go for it. Okay. For some reason, Mac is repackaging 6 8-pound bags of bird seed into 1-pound bags of bird seed. What is the least number of 8 6-pound bags of bird seed he needs to order to fill 1-pound bags without leftovers? Whew, okay. So he buys the 6 8-pound bags, and he's adding them all together, and he's turning them into 1-pound bags. So if I'm going to draw a picture for this, I'm going to flip back over to this side so I can have my problem 2. So what he's got, let's say I've got a nice little bag of birdseed, and he's buying them 6/8 full. So now that's 2, right? So now here's 4. And now let's go, I might as well just cut these all in half. So this is his bag of birdseed, okay? And he's buying them at 6/8 full. So 1, 2, 3, 4, 5, 6. So he's buying them this full. So every time he buys one, he has 2 8s left over. Double checking my work here. Yeah, he's got 2 8s that he needs more of, right? So if he buys another bag of birdseed that's 6/8 full, right? Half, fourths, eighths, and he gets all but 2 of them. He has another 2 8s left over that he needs. So you can kind of see where this is going. We're going to need to buy enough bags so that this leftover spot here equals 6/8. Because remember, he buys them in 6/8 chunks. So we'll do one more. Let's see what happens here. There's fourths. There is eighths. And again, they're all supposed to be the same width. I know, I'm just kind of doing it pretty quick here. So again, he's leaving 2 empty on top. Oops. So he's got another 2 8s empty over there. So he's got 3 bags he's purchased so far. And now if he buys up one more bag, what he can do with this bag that is 6/8 full again, right? Now we can start taking, let's say, this 2 8s right here and fill up the rest of this bag. He can take the next 2 8s and fill up the top of this bag. And then he's got 2 more 8s right there, and he can use to fill up the top of that bag. So he has to buy 1, 2, 3, 4 bags before he can get 3 bags full. So his smallest amount of bags he can buy is going to be 4. Like I said, I am literally going to walk you through these next couple because they, the way they're written, they're kind of like riddles. And so let's jump on to the next page. First problem is their example problem, but it doesn't really do you any good for the ones down below because each of these ones down below, the way it's written is a little bit different. So I wouldn't spend too much time worrying about this one. So we'll jump right on to 2. This one's a little more straightforward. Val walks 2 3/5 miles each day, while Bill runs 10 miles once every 4 days. In 4 days, who covers the greater distance? So we know that's easy. Bill's going to do 10 miles in 4 days. The question is, if Val is walking 2 3/5 miles each day, and she does that 4 times, will that be more than 10 or not? So I'm going to flip over to page 2, and we'll take 2 3/5, and we'll add it 4 times. Number 2. I'm going to take 2 3/5 plus 2, whoops, I'll make that a little bigger. 2 3/5 plus 2 3/5 plus 2 3/5. This is Val, and this is what she's walking each day, 2 3/5. So I'm just going to start with the column here. 2, 4, 6, 8 miles. But now we have to add up all the fraction parts. Remember from a couple weeks ago. So 3/5 plus 3 more fifths, that gets me 6/5, right? And then 3/5 and 3/5 get me 6/5 there. And 6/5 and 6/5, 12/5. So it has 8 and 12/5, which doesn't do us a whole bunch of good yet, right? From 2 weeks ago, converting these into a mixed number, it's a tricky skill, and I wish we could have spent more time on it, but we'll work on it on and off. So what we want to do is, how many full chunks of 5, how many full 5s can I pull out of 12 is the question. And the answer to that is 2, right? I can pull 5, I can pull 10 out of that 12, right? So if I did pull 2 chunks of 5 out of there, that means I'm taking away 10, which leaves me with 2 big ones and 2/5 left over. So now if I add those two together, then I have, when it's all said and done, 8 plus 2 is 10 and 2/5 left over. Whew, crazy, huh? Here's Val. 2 3/5, 2 3/5, 2 3/5, 2 3/5 makes 8 and 12/5. And then when I convert that back into a mixed number, we end up with 10 and 2/5. So Val is our champion. (10 2/5) versus 10 miles. Val's the winner. 2 more to go on this one. Chad buys peanuts. This one took me a long to figure out what it wants us to do. So Chad goes out and he buys peanuts, and they're from 2-pound bags. Now, unlike the bird seed, he is repackaging them into smaller bags. He's putting them in bags that hold 5/6 pound of peanuts. How many 2-pound bags of peanuts could Chad buy so that he could fill the 5/6 pound bags without having any peanuts left over? So he's buying more peanuts than will fit into the bag. Okay, so 5/6 is what we're looking for, and a 2-pound bag. This is where it gets a little bit not nice of them. So in this case, here's the big bag of peanuts. I need some extra room. And it's a 2-pound. I can't just divide this into 6 because it's 5/6 of a pound. And so right off the bat, we have to cut the bag in half. So each one of these bags, each half of this bag has 1 pound. LBS is pounds, right? So now within here, I can cut this into 6ths, which means I cut my best into 3rds, best I can, and then I cut that 3rds in half. All right, so in this bag, he's taking 5/6. And then in this side of the bag, again, cut it into 3rds, eyeballing it, and then cut those 3rds in half, gets me 6ths. All right, and again, now with this one 2-pound bag, he can fill one bag that's 5/6. He can fill another bag that's 5/6. But in this picture, these blank spots don't represent emptiness of the bag. This is peanuts left over, right? So for every 2-pound bag he buys, he ends up with 1 2/6 left over. So every 2-pound bag, well, this is going to be confusing if I just write 2 equals. So 2-pound bag, he's going to have 2/6 left over. Okay, so he wants to know how many bags does he have to buy, how many big bags before he won't have any left over. Okay, so let's double check here. He's filling them up to 5/6. Okay, and let's see if he wants it nice and even without having any peanuts left over. Okay, so in this case, for every 2-pound bag, he's going to have 2/6 left over. So if he buys another bag, if he buys one more 2-pound bag, he's going to have another 2/6 left over. And that will be 2 plus 2 gets him 4/6. Not going to do it, right? Because he fills his bag to 5/6. So he's still going to be short. He buys another 2-pound bag. That's another 2/6 left over. So now he's got 1, 2, 3, 6/6. And you would think this is great. That's 1. But that's not what he's doing, right? He's filling up 5 6-pound bags. So we need to keep on going until we get to a multiple of 5, right? So we need to go maybe to 10/6 if we can get there, or 15/6. Let's find out. Another 2-pound bag, another 2/6. 6/6 plus 2/6 gets me 8/6. Still not going to do it. And then one more 2-pound bag, another 2/6 peanuts left over. That gets us to 10/6. I think we're going to be okay there. Because with 10/6, with a 10 on top, I can pull 2 of the 5 6 bags out of there. Ooh, like I said, these problems are diabolical. So let's see, he bought 1, 2, 3, 4, 5 bags. It took him 5 2-pound bags in order to come up with filling 5/6 and never have a single peanut left over. So 1, 2, 3, 4, 5. Five 2-pound bags. Diabolical, I tell you. If I was teaching this in the classroom, we would spend a lot of time on the next couple pages, and then maybe we would throw one of these in it for a challenge at the end to see if we could work on it together. I definitely wouldn't just hand these out and say go for it. Okay, so the last one. Here's a carpenter. A carpenter's job is to cut and saw and build stuff. A carpenter has several boards, so he has a mystery number of boards, and that's what we're going to probably find out at the end, of equal length. He cuts 3/5 of each board. We're going to assume that means he cuts 3/5 off of each board, right? After cutting the boards, the carpenter notices that he has enough pieces left over to make up the same length as 4 of the original boards. How many boards did the carpenter start with? Whew, you can read that over and over and over again and try to come up with it, but let's just do it. So he's got a mystery number of boards, and when he is cutting them, he's only using 3/5 of the board. All right, which leaves him a little bit more. So I'll draw a small version here. So if he's got a board here, now I got to tell you, fifths, there isn't like a pattern block for fifths. Thirds is easy, sixth is easy. Fifths are tough to draw in a circle, right? You can kind of do it kind of like a stick figure with their hands up, but it's hard because this piece, is way smaller than this piece there. So 5s and 7s are often rough. So I'll do the best I can. I'm just going to go, let's see, 1, 2, 3, 4. So that's roughly this board cut into fifths, okay? So when he's going through, he's cutting 1, 2, 3. So he's cutting 3/5 off. That leaves 2/5 left over. That's in his scrap pile, okay? So he's got chunks of 2/5. So he says, after cutting the boards, the carpenter notices that he has enough pieces left over to make up the same length as 4 of the original boards. In other words, his original board is 5/5, right? It's 5 out of 5 pieces, and he's got enough of these 2/5 pieces to make 4 of those. All right, so to give myself a little bit more room, actually I don't even need more room, I can do this one right here. So if he's going to make 4 boards that are 5/5 long, then that means it's 4 5/5 plus 5/5 plus 5/5 plus 5/5. Pardon the penmanship. Okay, so this is what he has enough pieces to make. So 5, 10, 15, 20 fifths. Okay, so this is the amount he has left over, and so it wants us to say how many boards did the carpenter start with? So we want to know how many times will I have to have a piece that is 2/5 long to make 20/5. Does anybody see the relationship there? It's going to be 2/5 times mystery number equals 20/5. My guess is that some of you are keen enough to figure out 2/5 plus 2/5 plus 2/5, right? How many times will I have to go 2, 4, 6 before I end up at 20? And you are right. It is 10 times, right? So this mystery number is actually a 10. So 10 pieces that are 2/5 long will make one that is 20/5. Oh man, like I said, these are rough ones. 10 boards. How many boards? 10. Whew, if that was an absolute whirlwind and a mind bender, do not worry. Those are rough ones, and it took me a few minutes on each of them to make sure I knew exactly what it was asking. So don't sweat it if you're like, oh boy, that went way too quick for me. Okay, here you go. This is where it starts to get easy. Again, looks intimidating, right? But what it's doing is we're introducing the idea of multiplying. And by multiplying, I mean multiplying a whole number by and they're talking about this again, unit fraction. We talked about that in our workbook. A unit fraction just means a fraction with one top. And a whole number means the big number. So 7/10 is the same as 7, the whole number, times 1/10. But you kind of knew that already, right? 1/10 plus 1/10 plus 1/10 equals 7/10. So 1, 2, 3, 4, 5, 6, 7 of those. 7 1/10 equals 7/10. Okay? So I'll show you the example, and then you will be able to do this no problem. 2/5 says write the fraction as a product, and product, remember, means the answer to a multiplication problem, of a whole number and a unit fraction. So a big number and a fraction with 1 on top. So 2/5 is the same as, look at the top numbers, 2, big 2, times 1/5. Done. Too easy, right? Too easy. How about this one? 5/12 is the same as, top numbers are 5, so it's going to be a big 5, times, bottom numbers are 12, 1/12. Too easy. I'll let you do this one. And then when it talks here, remember multiples, we were just in my class getting into multiples. We were doing factors and multiples. We were getting started, but I think Miss Jacobson's classes did some multiples and stuff. So multiple just means we're counting by that number. We're counting by that. So the next 4 multiples of the unit fraction of this one, 1/4, get ready for this, 2/4, ready, 3/4, and so on and so on and so on. Same thing here, 1/6, this will be 2/6, 3/6, and so on and so on and so on. All right, next page. Write the fraction as a product of a whole number and a unit fraction, just like on the last page. 7/8 is the same as, the top number is a 7, big 7, times, bottom number is an 8, so 1/8. Same there, same there, same there, same there, same. No worries. And then again, list the next 4 multiples. 1/5 goes to 2/5, and then 3/5, and I'll let you go for the rest of those ones. All right. In this case, so far, Monica has read 5/6 of a book. She has read the same number of pages each day for 5 days. What fraction of the book does Monica read each day? So if this took her 5 days to get 5/6, then it's kind of like a division problem. How many would she do in one day? 5 days, 5/6, 5 days, 5/6. So she's doing 1/6 per day. Nicholas buys 3/8 pounds of cheese. He puts the same amount of cheese on the sandwich on 3 sandwiches. How much cheese does Nicholas put on each sandwich? He buys 3/8 pounds. He divides it between 3 sandwiches. Same situation as over there. All right. Now, this part is where you realize just how easy it's going to get. After having seen all that stuff, you can see 1 times 2/5, right? And then 2 times 2/5, 3 times 2/5. And we'll go down here. We're going to do multiples of these, but instead of going 3/4 and then 4/4 and then 5/4, we're counting by this number. We're counting by 3/4. So the next one would be 3 plus 3 is 6/4. Plus 3 more, 9/4. Plus 3 more, 12/4, right? So 3, 6, 9, 12. I'll let you fill the last one in. Same thing here. 5, 6, we're counting by 5/6. On the previous page, we were counting by a unit fraction. Now we're counting by like our straight up fraction. 5, 6, one more of those would get me 5 and 5 is 10/6. Another one of those would get me 15/6. 5, 10, 15, bang, bang. I'll let you do those last two. All right. So here's the grand finale. This is where they want us to get to. It took us 3 pages to get here, but here we are. When I multiply a whole number, hold on, make sure this is focused. Hope you're sitting down for this. Yeah, I'll back up. When I multiply a whole number by a fraction, all I have to do is take the big number times the top number and then keep the bottom number the same. Because 3/8 times 3 we know really is 3/8 plus 3/8 plus 3/8, right? It's 3/8 3 times. 3, 6, 9. Or, to make it quick, 3 times 3 is 9/8. Too easy. 4 times 2/3, it'll be 4 times 2 is 8/3. And it doesn't say anything about converting them back into mixed numbers or anything like that. So we're just going to leave it with the fraction bigger on top. We're just going to leave it as an improper fraction for now. My guess is in a week or two they'll have us swapping them back and forth. Okay, flip it. Next 4 multiples. Again, counting by that top number, 3/5. The next one's going to be 6/5, and then 3, 6, 9/5. You get the picture. Counting by 2s, 2, 4, 6. Counting by 4s, 4, 8, 12. Counting by 5s, 5, 10, 15. All right, and then down to here, back to where we found out the easy way. Big number times the top number. 2 times 4, 8/5. Same there. And now they're getting rid of all the extra stuff we did, and check it out. They think this is super tough, but it's not really tough. Big number times the top number. 6 times 2, 12/3. 2 times 9/10, right? 2 times 9, 18. 18/10. All the way down, same thing. Including this. It even says multiply fractions by a whole number using models, but they don't really give us a ton of room, nor would it make much sense because I just told you that drawing fifths is really not easy. So we'll just do what we know we're going to do for the rest of our lives. Big number times the top number, keep the bottom number the same. 3 times 2, 6/5, 6/5. Do the same. Whew, okay, math part's looking good. Real quick, nothing different here. Read the story, answer the questions that's got on there. This part is some more spelling. In this case, made it a little trickier. They gave you a full paragraph. It says, proofread the story. Help Maggie edit her story about a family member. Circle 7 misspelled words. Then write them correctly on the lines below. Use the list of spelling words to help you. Here are all the potential words that could be misspelled. You can see this time it's way more than 7. All right, so kind of go through and double check. I have a very V-E-R, V-A-R. Let me just check to see if there's a V word in here. No, that must be right. Pleasant, this is suspicious. P-L-E-A-S-E-N-T, pleasant. Let me just see if there's a pleasant in here. Well, let's check it out. P-L-E-A-S-A-N-T. E-N-T-A-N-T. Okay, this is my first one, pleasant. And I'll spell it correctly down here. P-L-E-A-S-A-N-T. Pleasant instead of pleasant. Okay? And then down below it says proofread, circle the word is spelled correctly. So here's the word breath or breathe, and it's spelled 3 different ways. And if you look up here, it tells you how they spell it correctly. So no worries there. Lastly, pretty much just vocab on this one. These are I-O-N words with the suffix. This is justification, pollution, suggestion, quotation, correction, proclamation, audition, publication, improvisation, transition, and altercation, and election. You'll find there are 12 words up here, only 10 down below, but then it gives you this last one. Choose 2 words from the above list and write a sentence for each word. It doesn't say choose the 2 you didn't use, so you could use any one of these ones you want to. So if you happen to know what audition means, because you watch a lot of American Idol or something, or The Voice, then you can write your sentence about that. If you want to say correction or transition or pollution, those are ones you can write about. Hey, everybody, have a good week.